Alright, so I've actually made quite a few little changes to this Leadscrew printer now, and I just wanted to do a video update to kind of document them. So I guess one of the most simplest changes was changing that from a rigid coupler to a flexible coupler. It's still rigid on this end because it's got that bearing with the locking nuts there, the little collar thing. So that there stops the lead screw from going this way, and also it's jammed up against the shaft on this end to really stop any play that way. But it can still move this way a little because basically the lead screw isn't quite straight. It's a little bit banana shaped, I guess, only very subtly. But you could, if you look hard, you could see the lines in the prints. And in fact, here's an example. This is actually after I've put that coupler in, but this is better. So it's actually kind of hard to see, but if you get in the right light, especially with this silk filament, really shows up things like this, you can see lines going down. And those lines are every 8mm, which is, so one rotation of that lead screw is 8mm in this direction. So that's what that cause is, but this is actually a lot better. And like I say, silk PLA seems to show it up a lot more. So I mean, in reality, this is quite a nice print. Yeah, so that, I think this is acceptable now. Much better anyway. Next upgrades. Well, the orbiter's a nice, lovely feature now. So we used to have the extruder at the back. I've got this orbiter too to shorten up that filament path. So I ended up mounting the orbiter 2 on this tiny aluminium bracket that I made up, which bolts to two of the bolts from the MGN12 rail. So that was a nice, easy installation. While I was at it, I used this single cable here rather than the two Ethernet cables I had before. This is a like a 25-pin serial cable, just cut off the ends, and used that and doubled up the wires where I needed extra current. And then I've also got extra negative wire for the heater in there, just to make sure I can get enough current going to the little heater. This heatsink's changed. This one seems to work actually quite well. I don't think that the Intel Nook heatsink was really, well, it didn't have a fan to start with, and I think ideally it needed a fan to work well. So this is good, more compact, does the job. It's actually the heatsink which used to be on this stepper motor. So this stepper motor, so this whole axis, that was a big thing trying to get the speed up. So basically, as it stands now, I can get 90mm per second max, which is still limited on this y-axis, but yeah, I ended up changing to this stepper motor. This is a 0.9 degree stepper motor. It's much longer because I thought, well, I need more torque. I need a bigger motor. So I ended up cutting the back out of the plastic here so I could fit a longer motor. Eventually I'll probably make a cover if I ever want to enclose it all. But that wasn't the issue. The biggest issue as far as getting maximum speed was higher voltage, because as you can see, I'm running on 14.1 volts for the whole system because it's a 12 volt heater, 12 volt bed. And I guess I forgot about the back EMF issue with the stepper motors. Basically, you need quite a lot of voltage if you want to go really fast. I ended up changing that pulley to 20 tooth rather than 16 tooth because I thought, hey, maybe that'll help. Did basically nothing. So I've kept it at 20 tooth because it did basically nothing, and I don't know, I think you get more belt wrap with the 20 tooth, so kept that like that. And I'm actually using a 20 volt power supply at the moment, and I've got a 36 volt power supply on order. Is it 36? I don't know, it's much higher. And I will tip the printer over and show you how I'm running 20 volts into that stepper motor and 14 volts for everything else. 14 volts for this stepper motor, 14 volts for that stepper motor. Okay, so here's the base of the printer, and you can see here there's the Big Tree Tech SKR Mini E3 V2. And then here you can see an external stepper driver, and that is a 22 2208, and I chose the 2208 rather than 2209 because this can handle, I think it's 36 volts. Basically, it can handle more voltage than the 2209s. So yeah, this is how I am running that Y stepper at a higher voltage compared to the onboard steppers. So there's a little plug, connection there which goes down to this 20 volt power supply, and I could actually mount this little power supply here, which is what I'll do if I decide to stick with this. But as I say, I've got a 36 volt power supply on order, and we'll see how much more speed that gets me. And another issue is I can't run stealth drop, and I'm not sure why. It tries to home, then when it gets to the home point and it tries to go back, the stepper driver errors, and I haven't worked out what that error is, but I think it's probably something to do with not enough torque to go back. Not sure exactly, but that's something that's happening at the moment. And yeah, so I've got stealth drop off, so it's a little bit louder, but yeah, it's not bad. But yeah, basically I've got various jumpers going down to the main board to get power and signal to this extra driver. Originally I was hoping to just use this connector here, but I think I fried one of the pins from experimentation, so then I had to run another wire. Then I was basically running that on 5 volts because that's what this gives you. Then I realised the MCU is only a 3.3 volt MCU, and I don't know, I didn't do any testing, but I don't know if you run this off 5 volts, does that mean the data line is pumping 5 volts back to the MCU? Not sure. So basically I found a 3.3 volt line there to actually power that, just to be safe. So I'm not sure how that works. So that is that. Those are the upgrades at the moment.